example 3, we're going to look at what happens to the parent function y equals square root of x when we add a number outside the radicand. And we're going to call that number k. And we're also going to specify, as I told you in the last slide, what is the domain and range. Well, first, let's look at what the values look like. And we're going to use y equals square root of x. And we're going to say square root of x plus 2. All right, let's do our table. And as we do the table, it's helpful to think about how is this different than the parent functions that we've been doing and the functions where we had an a value. Well, when x is 0, you'll notice y is no longer 0, y is 2. When x is 1, you'll see y is 3. When x is 4, you'll see y is 4. And when x is 9, y is 5. So let's graph, and we need to go up to 9 on the x-axis and 5 on the y-axis. And let's see, we need to go up to 5, so about here. Okay, now I'm going to go back before I move forward. And I always want to draw the parent function is because I want to make sure I'm comparing to the parent function. So the parent function, if you remember, was 0, 0, 1, 1, and then 4, 2. And it looked like that. Y equals square root of x. I'm going to draw in green what happens when we add 2. 0, 2, 1, 3, 4, 4, and 9, 5. And what you can see is that the shape is exactly the same, but just 2 units up. So if we were to describe it, we see it's a vertical translation, 2 units up. Okay, and obviously if this was -2, it would probably be here and be 2 units down. And that is very important as we move forward. Now, as I mentioned before, we have got to specify our domain and our range because that's different here. And so if I do that, let's see, my domain, in other words, my x values, same as before, x is greater than or equal to 0. Pretty clear. But what happens to my range? My parent function, it was y is greater than or equal to 0, but here, y can't go below 2. It's stuck because I can't do negative numbers for x, and there's no way that it can go further down. So my y value has to be greater than or equal to 2. So that is what happens when you're adding a k value outside the radicand. What happens if you add it inside? Well, because we're exhausted, we've figured out what makes it shrink, what makes it stretch, what makes it go up and down. The logical conclusion is we're now going to talk about what makes it go side to side. And as you can imagine, that's going to affect the domain and the range. And we'll look at what happens there. So now we're going to take our parent function and we're going to say y equals what happens when there's a value in there. And I'm going to call that value h. And we're going to make minus h our base problem. And I'm going to use, as an example, y equals the square root of x minus 4. As we've done before, let's make a table and see what happens. Now, of course, as I've done before, my first number I want to put in here is a 0. But if I put in a 0, look what happens. 0 minus 4, I get a square root of -4, which is impossible. If I put in a 1, the same thing happens. If I put in a 2, a 3, the first number I can put in and not get an answer that can't occur is the number 4. So the first number I can actually put in is 4, and I get square root of 4 minus 4 is 0, and square root of 0. I can also put in 5. 5 minus 4 is 1, square root of 1 is 1. And let's see, I can put in 8, because 8 minus 4 is 4, square root of 4 is 2. And let's see, if I can fit it, I can put in 13, because 13 minus 4 is 9, square root of 9 is 3. Okay, here, if I graph, I need to go out, let's see, in the x-axis to 13, so I need to go up very far with in the y direction. Let's see, so 5, 10, 15, not as even as it should be, but and here I'm going to go up 0, 1, 2, 3. All right, again, let me do my parent function. And my parent function would have been 0, 0, 1, 1, 4, 2. And there's my y equals square root of x function. I'm going to do my new function, y equals the square root of x minus 4 inside the radicand, and I get 4, 0. So I'm starting here. So clearly, I've moved 4 units over from 0 to 4 as my starting point. Then 5, 1, and then 8, 2. Let's see. And then 13 all the way out here to 3. And that is the equation y equals the square root of x minus 4. Okay. So what has happened? Well, you can see the whole thing has shifted. And so we're going to have, compared to the parent function, a horizontal translation. 4 units to the right. Sorry for my handwriting. Believe it or not, if you saw where I'm writing, you'd understand why it's very hard to get this little corner. All right, so here I could show that it was going up and down. Here it's going to the right, and of course that's going to really significantly affect our domain and our range. And let's look at how. So my domain here is I have x is greater than or equal to 4. I can't go below. Remember, if I put in a 3 or 2 or 1, I get a negative square root, which cannot happen. And so I am stuck starting at 4. So my domain is x is greater than or equal to 4. No longer x is greater than or equal to 0. What is my range? Well, when x is limited that way, it looks like y, I am able to do anything above 0. So y is still greater than or equal to 0. So that concludes the first half of 11.1, and I will give you the second half tomorrow. We've explored what happens when we multiply y equals square root of x by a, what happens if we add a number outside the radicand, what happens if you add a number or subtract a number inside the radicand. Remember that if this was a positive number, if I had x plus 4, it would move it to the left. Okay, so that you can end up with negative x values just if you move this to the left. please do the homework. It should not take you too long. I have tried to limit the number of graphs, and I will see you tomorrow. Take care.